Welcome back to the Hub Pavilion here in Copenhagen, and I'm really excited to be joined by Tony Haymet, Dr. Tony Haymet, and you're the director of Scripps Oceanography. Thanks very much for coming along. Tell me, first of all, why are you here in Copenhagen?
Well, we've come here with a few scientists and some of our PhD students to be a science provider. We have a number of issues that we're trying to bring to all the policymakers here and make sure that they know the latest science.
So tell me first of all about the CO2 in the oceans and what the acidification and what maybe some specific examples of what that does and why you're bringing this to leaders' attention.
Well, sure. 52 years ago we started measuring the CO2 in the atmosphere. Our colleague Charles David Keeling was the first to do that. And we've kept doing it every month for 52 years. And so we now know that after 150 years of the post-industrial world, we've increased the carbon dioxide in the atmosphere by 39%. So what that means in simple terms is that for every 3 CO2 molecules that nature put there, we've put another one ourselves. Mm-hmm. And that has two effects. It has the warming effect that we hear a lot about. But the other effect is that some of that CO2 dissolves in the ocean, since 71% of our planet is covered with ocean. So we've disturbed the equilibrium of CO2 because we've increased it in the atmosphere. And so 22 years ago, we started measuring the pH of the ocean. Unbelievably, it was the same guy, Dave Keeling, who started the measurements. They've been kept going by many scientists around the world. And so we've seen that in that same industrial period, we've increased the acidity of the ocean 30%. Now, if you think about the vastness of the ocean, that's sort of an amazing factor.
Incredible, yeah.
So, some huge fraction of the tons of CO2 that we've emitted has ended up in the oceans. And probably even more important, there are tiny little things called pteropods. They're sea snails, actually very beautiful. But they're a tiny little thing about the size of a child's fingernail. And just about everything eats them. Salmon eat them in a very important stage of the salmon's life. Little fish eat them, and of course the big fish eat the little fish. When the acidity gets too high, these organisms have a lot of trouble excreting their calcium carbonate. And if the acidity were to get even higher, they would start to dissolve. So this is not an abstract problem. This is not something that's coming at us in 100 years or 300 years. This is something that may be affecting our fisheries right now. And we think it brings a lot of focus to the issue. It's a problem that affects every nation. Indeed, when you figure out the effect on fisheries, it probably affects China and the United States just as much as the developing world. So we think, therefore it's kind of a leveling issue. And it's very simple science. CO2 dissolving in water, that's Perrier.
Right.
There's no denialist community.
Yeah.
Probably will invent one. But it's a very simple measure.
And is there any solution? Is there any geoengineering solution?
There's one solution, and that is to stop putting CO2 in the atmosphere.
Right.
And again, that's a very clarifying principle. A lot of the geoengineering solutions put little umbrellas between us and the sun, or the molecular equivalent of that. They won't help this problem. They might mask the global warming, but they won't stop the oceans from becoming more acidic.
Dr. Haymet, thanks very much for coming to speak to us here in the Hub Pavilion in Copenhagen. I'm Edie Lush.